the stuff here. You never know, you know. All right, we are recording. Welcome to week 5 of CIT 225. Let me share my screen. All right, I got all this stuff here. I'm gonna close all this stuff out. Boom, boom. Go away, go away, go away, go away. There we are. All right, here we are. So this week we're going to talk about June. We're going to talk about joins that we talked. Last week we talked about inner joins. Today we're going to talk about outer joins. There was a question. There was a question online. Someone asked about the except operator. So there's so we talked about union last week, right? So union is where you take two select queries that have the same number of rows in the select, and you run it. And it's, so I have this one. It's like last name.
Excuse me. I think union is this week.
Well, we talked about it last week too.
Oh, okay. Sorry.
Yeah, we talked about it last week. Yeah, we talked about it last week too.
Could you zoom in?
What's that? Oh, can I zoom in? I can't. I don't know how to.
Well, actually, in the database, you can. At least on my laptop, I can actually make the text bigger just by.
Oh, I can make the text bigger, I think.
Yeah.
Let me
That's
see.
a start. But...
Let's see. How do I make the text bigger? I've never had to do this before. Let me figure this out.
Maybe it's control and you got a scroll wheel. You know?
Let's see. Nope, that just brings up and down. Tool view. Panels, no.
No, you gotta go to file preference.
Oh, preferences. Okay, file. I don't see preferences.
Somewhere preference. Somewhere where you say preference.
Tool server preferences.
No.
Help. Nope. Help.
That's strange because like on my laptop I can do like 2-finger, like just spreading it.
Yeah.
Okay.
Oh yeah.
You go to edit. You go to edit.
Edit.
Yeah, preference.
Preferences. Okay.
And you're gonna go to fonts and color.
Okay.
And here you set up whatever you want. This. Then you have to restart the system. I got it like on 14, and you make it very big. Mine is big. Because I have.
I can change this to
14. 14 is good font size.
14. Okay. Click OK.
I put everything 14.
Okay, so let me close this out and let me new query tab, and then we're going to connect it to database, and then that's good. Okay. Oh, yep. Is that better?
That's better.
Okay.
Thank you.
Yeah. 8 years teaching this, no one's ever asked that. So when I used to lecture on the Microsoft SQL Server, I used to have a tool on my laptop that would like zoom in. So that's what I was looking for. Okay, so last week we talked about inner joins. So here's a quick inner join. I've got use my use Sakilla before I get that error. Use Sakilla. Okay. I just have this inner join. Select A last name as actor, C last name as customer. From actor, on A last name, you can see last name. Now, this differs a little bit. So let's talk about inner joins real quick. So when we inner join, we want to join with this on clause needs to be a column that the two tables have the same. Okay. A lot of times you will see the column like the ID column or something that has a foreign key to it. It does not have to be foreign keyed. It could be any column that exists in both tables. And they don't have to be named the same either. It could be any two columns that have the same data in them. Like if this is called last underscore name and this is called L name, they can be joined on it. Okay. The reason why it's better to do on an index column is, or it's a foreign keyed column, is because then that column is indexed. Because so we don't talk, look at it, we'll sidebar here for a second. We don't talk a lot about indexes until there's one chapter, I think chapter 11 or 12, and week 11 or 12 talks about indexes. So I don't think I've talked about, let's talk about indexing for a second. I haven't talked about it in a long time. Indexing in databases. So, let me pull up my whiteboard here. MS Paint. Okay. So we'll do this here. So, let's talk about how we're going to go down a tangent here for a few minutes because it's interesting. I love this topic. How data is stored on a disk. Okay. So when you have a database, everything that is in your database is stored on the disk, but it's stored in a very, very specific way. Okay. So there's a system, a thing on the data is called a page. Okay. On your disk, you get pages, and a page is 8K of data. Okay. Every page is 8K of data. Okay. So when the database writes, when the engine writes the disk, it writes in 8K blocks. Okay. Every row of data has a limit to how much data can be in that row. How many bits of not 8K, 8 bits. That's per method. So that's 8 bits, not 8. I mean, that's going to bug me if I don't fix that. Hang on. Okay. So every page holds 8-bit, and whenever the engine writes the drive, it records in 8 bits. That's why, depending on the engine, is how much data can actually be in a row of data. Okay. That's why last week, if you watched the video last week, we were talking about how important data types are, because the data type will determine how much row is that, how much space in that data. So, so it's all written to pages. Now, the pages are stored in something called an extent. And one extent is 8 pages. Okay. So let me see if I can copy this here. So one extent is 8 pages. Beautiful. Okay. And you have these extents. So your drive, the space on your drive is formatted to look like this. When the engine writes to the page, it just basically goes, okay, goes here, goes here, goes here, goes here, and it starts writing across, right? So every time it writes, depending on what table it writes to, is where it is. So let's say this was writing to one table, and then it starts writing to another table, and then it starts writing to another table, and then this table gets written to again, and then this table gets written to again. Okay, so you can see where this can start to get confusing, right? So what the index does, the index doesn't exist in this structure. It is in a different memory structure altogether, away from all this. Okay, and what the index is, it looks for the column that you want to index, and then it tells the database where that column is. So it'll say, okay, you're looking for row 6. That's in extent 2, page 3. And then it'll go get the data from there. That's what the index does, right? So let's put a little index structure over here. It just is for a visual. So this is my index over here, right? So it has where everything is located. It's exactly like if you look at a textbook and you go in the back, you've got the index in the book. It tells you where the stuff is, right? It's exactly like that. That's exactly how it works. Now, when you delete data, so when the index is built, everything's in order, right? But when you start adding more pages to the extent, that information doesn't go in the index where it would normally belong. It goes to the bottom of the index. Okay, so the best example I do, have you guys ever like collected baseball cards or comic books or anything along those lines?
Yes.
Anything you've had to organize, right? So you get your baseball cards, you've got all your packs, you organize them, you've got the Mets and the Yankees, everything's in your little book, the book of pages, right? And everything's in there. And then you buy 6 more packs. And they've got to go somewhere. So you put them in the back of the book to be done later. Okay? So what this is referred to as fragmentation, which is a term I'm sure we all know. And so this is fragmented, right? So, and let's say just for fun here, I go and let's see, we delete this data out and we delete this data out and we delete this data out, right? Now, when the data writes to it, it starts overwriting what was here. And even though these are the same color, they're completely different data because everything's being overwritten, because databases never give up space. They only take more. Okay.
Similar with the operating system.
Yeah, exactly.
Indexing of data.
So it reuses space, right? So now all of a sudden, what was just mildly fragmented becomes incredibly fragmented because the index thought something was here and has an index that used to be there, but it's not there anymore. So when the query comes and says, hey, where's this piece of data? So, oh, it's in extent 1, page 5, and it goes here. I said, wait, it's not here. Oh, wait, let me go to the bottom of the index. It's here. So when you defrag the database, 2 things happen. The first thing is that it aligns all this stuff together here. So we got 3 green. We're going to place it with these 2 red, and then we got 1, 5. So I'm just going to make this up as I go along here, right? And then it's just going to basically put everything back into the order it's supposed to be, right? And then
that would speed up queries too, right?
It does speed up. So, and once this is done, it rebuilds the index. Okay, it rebuilds the index, and everything gets faster because now the index the index makes sense again. Okay. Now, here's the other thing. If we delete a bunch of data, like I said, oh, you know what? Hang on a second. I made one slight mistake. So when you delete the data, it doesn't reuse the space. It keeps it empty. Oops. Somewhere here. Anyway, so it keeps it. So let's say your data looks like this. You got a bunch of empty space here like this. And there is something we can call, we can defrag a database. And what happens is it takes all this empty space and we can shrink a database. Okay, there's a command called dbcc shrink, and you can shrink a database. So let's say this database is a terabyte and it's got 600 gigs of free space. You can shrink that database. Okay, but the problem with shrinking a database is it permanently breaks the indexes. And this is important. I mean, if you guys are ever in a database administration role and someone tells you to shrink the database, the answer is irrevocably no, we do not shrink databases because it permanently breaks the indexes. So that means you have to drop and recreate the indexes to get them fixed. And the problem with that is if you've got a database that's tables are like terabytes big, you're talking 3 or 4 days to build an index. Okay. How did we get on this topic? What were we talking about? Oh, we were talking about we're talking about the index. Yeah, so that's what we're talking about. So we're talking about the indexes. So the indexes are key. So your primary key is a default index. Whenever you create the primary key, it's a default index. Your foreign keys become default indexes. Okay, and how the data is stored, how the indexes are built in the metadata here. So if you look to the back of a textbook, you'll see dogs, and then you'll see herding dogs. And under that, you'll see different breeds of herding dog, right? The same thing is true in a database. Your primary key is your default index. That is what it sorts by default, no matter what happens, unless you tell it different. If you run a select query with no order by, it orders by the primary key column. If you tell it to use a different column, it uses that index. If you use a column that's unindexed, your query takes much, much longer. Okay. So if you're running something like this here, where you're doing an inner join on last name, that column is probably not indexed. Okay. So it will do it. It will just take longer. So that was a sidebar. So here I'm joining on last name and I'm ordering by the last name. And again, the A is an alias because in order to identify which table this column comes from, I have to let it know which one it comes from. I could just type the word actor here, but it's so much easier to type A. So I'm going to go ahead and run this query. Oops, let me do the whole thing so it actually runs. Okay. And so here we got, it just gives me my inner join. Okay. Back up here to union. A union takes the results of two separate select statements, and as long as the number of columns in the select statement is the same, it will always work. So here, I will run this, and it shows me, get this out of the way. I have 43 rows returned. And here's the last name and the first name from the, last name and the first name from the different places, okay? Remember, union all returns everything, even duplicates, and union returns everything but the duplicates, okay? Now, that's how, so the union, there is an intersect operator that does not work in MySQL. It's funny, someone had posted a question to my announcement, and it said, does the accept and intersect operators work in MySQL? Because according to the textbook, it doesn't, but according to the quiz, it does. So up until version 8 is when it started working. It was this version that's there now. In version 8, it started working. So the textbook is for version 6, 7, and the test was not written. Wait. The test was not written for MySQL. The test was written for a generic T-SQL language, okay, where accept operators exist. So intersect operators do not exist in MySQL, but all they are is an inner join. So here, instead of union, you'd have intersect. Let's see if it'll work. Intersect. Yeah, see, it doesn't change color, so intersect doesn't work here. Now, accept should. Okay, so now what accept does, it says, show me everything here except where this matches. Okay, so that's what accept does. It shows me the difference. So it shows me the difference between the two. And if I reverse these, if I change actor to customer, customer to actor, I would get a different result, obviously.
Yeah, this goes along with your overlapping circles.
Yeah.
Video you did last time.
Yeah. So that's what it is. So so this tells me, give me everything in customer that isn't in actor. So this is kind of the opposite of a full join. The joins we're full joins we're talking about here in a second, okay? So accept works in MySQL. Intersect does not work in MySQL. Intersect works everywhere else, just not in MySQL. And up until a year and a half ago, accept didn't work in MySQL. That is a new addition. So imagine the fun teaching this class 3-4 years ago, where the accept query was there, the accept clause was there, and it didn't work.
So
okay,
what is the question he's saying on the exam?
Oh, no, the guy was just asking, did the accept query? The guy asked, does the accept query work?
Okay.
In this, as far as the exam, the quiz for this week is concerned, I think they mentioned the accept query. I think they just ask what it does. I don't think it's been. I don't really look at the quizzes. I looked at them once a long time ago. And oh, I forgot to mention this. If you guys ever find a mistake in the quiz, let me know, because they finally gave me permission to change the quizzes, which I've been doing. Actually, at this point in time, I can change whatever I want to in the course. But I don't change a lot. Like, for example, what I require for the final project is not what the syllabus says. It's very different. And I do that for two reasons. One, because I think what they want for the syllabus is too much. That's just too much. I want to simplify it, make it fun. What they have isn't fun. Two, I want to torture the people that don't watch my videos.
I'm glad I'm here. Do we want to turn the recording off?
That's it. No, it doesn't matter. So we've got 22 people in this class, right? And I just, because, I'm curious, only 5 people have watched this video. There are people in this class right now who are already into week 8's work.
Yeah, you said that like 2 or 3 weeks into it, they were like somewhere halfway done with the course. So,
and they will invariably ask me about the final exam of the final project. I'm like, okay. Or my favorite is when they turn the stuff in based on what was in the syllabus, and it probably takes 4 or 5 times longer to do the final project based off the syllabus. And every once in a while,
typo in last week's. I think it was the worksheets that we're doing.
Oh, really? Yeah. Let me know. I can go and fix. I'm trying to fix all those out. There are some questions that are. I think I've got them all, but there's still some that are wrong.
Okay.
That I need to go and fix. I'm trying to get those in. But if you ever see a question that's wrong, let me know, and I'll go and fix it.
I'll go back later and try to find that. If I can.
But the what was I saying? So so the quiz in here has, I think it says, what does the accept query do, or what does the accept clause do? I don't think there's an exercise that asks for it. And if there is, the answer is in the back of the book. So, like I said in week 1, if you ever get stuck on an exercise, just go to the back of the book. Until week 7 or 8, everything is in the back of the book, and then at 7, then you can always tell the ones that they added in on the exercises, because they're ridiculous.
Yeah, this last one, there was, I think, one that wasn't even in the back of the book.
Oh, they added one here. Yeah. So yeah, so I don't. Go ahead.
I was like, wait, this isn't here.
Yeah, they throw those in. I mean, it's good that they do. I have no problem that they use the questions from the book, because for me, one of the best ways to learn coding is to see something and then reverse engineer it. You understand how it works, right?
It's on GitHub and all these sites that people take code from, and they learn from each other.
Yeah. The funny thing is, so this course 6 years ago was taught for Oracle. We taught in the Oracle database system, and it used VMware. You had to download it was a nightmare class. It was an absolute nightmare class to teach. But that course had been around so long that there was a GitHub repository with the answers to everything that people were just downloading and submitting. And because it's code, plagiarism's a tough thing to do, right?
Yeah.
Because code is code. You can't say, if you use someone else's code, it's just code. I can't say, unless you put let's use someone, what's their name? Like what was it? I was reading the other day, English teachers with ChatGPT. Since everything's online now, they read their prompt online. The students are just copying the prompt and pasting it into ChatGPT, and the ChatGPT is pushing out the essay, and the kids are taking the essay and putting it in there. But what the teachers are doing, and this is smart, because the kids will never figure this out. Even if you tell the kids they're gonna figure out, the teachers at the bottom, because they just select everything at the bottom in white text that you can't read, said like, and include the word unicorn and potpourri in the essay. So when they use ChatGPT and they paste it in, they don't see the whole thing about using the 2 words. And then all the teachers do is scan the essay for those 2 words, and they'll know they use ChatGPT to do it.
Do they paste it without formatting?
Well, it doesn't matter because when they copy the prompt in.
Yeah.
Yeah, they just copied it because I've done the same thing. I tested it out. I went to an ACT website and took one of their prompts and dropped it into ChatGPT. Came out with an essay.
Yeah.
And then I did it with the white text with it. I said, use the word pineapple. Popped that, and then right in the middle there was pineapple.
Yeah.
So
it's
still text. Yeah, it's not special formatting.
Yep, it's not. It's just a different color.
Yep.
So it's not special formatting. It's just copy and paste in.
Right.
And you outsmart those techie lost generation kids, right? All right, were you gonna say something, Pablo?
Yeah, no, that was smart because these kids nowadays they just care about passing the class.
Oh yeah. And I mean, even in this, I mean, to a certain extent, I understand that. Like in this class, there are people who take this class who've done databases for years, and they don't need to hear me talk about them. So they just go in and push through, and they just check the box, and they pass the class. It's the same thing when I take classes now. For every once in a while, I'll take a class for a database, and I just wait for when they talk, like when they do the new version of Oracle. I'm in that 23C class, and they're talking about everything Oracle has done till now. And the last 5 minutes, it's what the new stuff it is, and I just pay attention. But I've got to be there the entire, 37 hours of class, right? So, anywho, so let's talk about add the joins here, okay? So, I've got select last name as actor, last name is customer from actor, and I'm left joining on customer on the field last name and I'm ordering my last name. So what's going to happen here? It's going to return everything that's in the actor table and only return the values that are in the customer table that match. So what's going to happen is when we look at these results, we're going to see a bunch of nulls in the C last name column. Because in customer, there is no Ackroyd, there is no Astaire, no Bacall, right? So we have all these nulls here. So that's what the outer joins do. They give you all the results from the one table you're asking for, and then the results that match in the other column, in the other table. This is used a lot for merging tables to find where data is. Like if you're buying if you're merging 2 databases from 2 similar companies, and you've got 2 customer tables, you can like match on certain things and show on the left join. You have, here's my company, here's the one I bought. Show me all the names here in the new companies table that aren't in mine. And I do that with the join, that join. Right join does the exact same thing, except the opposite. So it's going to turn everything from the customer table, but only the things that match in the actor table. So I run that, and again, it's the exact opposite. Abney, there's no Abney, there's no Adam, there's no Adams, Alexander. It's all of these things here. Notice there's no Ackroyd because that's not in the customer table. Now, if I'm doing this right, there is another one called full joins. Okay. Full join does not work in MySQL. At least I don't think it does. Let me see. Full, no. Yeah, full. Oh, maybe.
After version 8.
Maybe. I haven't tried this in a while. Full, outer, maybe. Let's see if this works here. You gonna work? Oh, it errored. It doesn't know what a full outer join is. So, or full join, will that just work? Nope. Okay. So, what a full join is, it looks like this, and this should work. You don't like that. What don't you? Oh, this here. Get rid of that. There you go. That's what a full outer join looks like. So it takes the result of this left join and this right join and puts it in the same table. So it's pretty notice how it's like twice the size of the two tables combined because like of whatnot, right? So yeah. So that's what the full outer join is. I think the full outer join is just a neat party trick. I don't know of a reason why anyone actually uses it. I've been doing this 20 some odd years. I've never actually used a full outer join for anything. But I bring it up because it's a completion thing. There are two joins that I don't talk about because I don't like them and they're never used. One is called a cross join. You'll see a question about that on your quiz. A cross join is what they refer to as a Cartesian join. And what it does is just returns things in the order that they're in the table. It doesn't work like a regular join. It just, when you have, I don't even do an example for it anymore, but it just returns things in such a way. It's like, it takes the order they were in the tables and puts that out. The other one, and this is how you can tell an old coder. Here, why not? Give me this one here. No, I want this here. Oh yeah. This should work. Yep. So here you go. This is showing that you completely trust the database engine to do the right thing. So you're saying select from actors and customer, order by last name, but you join it the way you think is right, database engine. Use whatever column that you think is the good choice, and we'll make that work, right? So now notice that the results look very different, right? So it just does what and if you'll notice also what happens here. Oh, does that do that? Oh, wow, okay. Okay. I just realized, been doing this a while now, but the comma. So in any other database platform, the comma is basically an inner join. So if you do table, comma, table, it can treat that inner join and joins the way it is. Apparently in MySQL, and I've never looked at this before, it treats it like a Cartesian join. So this is what a Cartesian join result looks like. It takes the first column in the first table and matches it to everything in the second table. And then at the end, it goes to the second one. Oh, no, it's not doing that. Oh, it's because I got to do this. There we go. Notice we've returned 120,000 rows at this point. So now when I start going down, there you go. See now Dukakis. So what happens is in a cross join, which is what this does, it takes the first value in the first column of the first table and matches it to everything in the column of the second table. I have no idea why this exists. And I don't, and it's really weird to me. And again, doing this a while, everywhere else where you put the comma there, it's an inner join. MySQL decides to make it a cross join. But now you can see why we don't use cross joins. That covers the code that I had for tonight. We're 10 minutes to the hour. I'm sorry I got sidetracked on the indexing thing. I just love how databases work. I think it's so interesting how databases store data on the disk and retrieves it. It's to me, it's just I can talk for hours on that. And if we were in a room with a whiteboard, I would draw pictures for like days on how this works. Particularly when it comes to the subject of fragmentation of indexes. When you're are either you planning to be database administrators, or is this just a course you got to check off to do whatever you're going to do?
It's a check off for me.
Yeah.
I am doing it because I want to use it in combination with Microsoft Excel to see.
Oh yeah.
Business analytic.
Yeah. There's so if you really want to get into analytics, I suggest when this course is over, go to the Microsoft website and download SQL Server Developer Edition and learn about something called SQL Server and SQL Server Analytics Server. Because SSAS, it's called SSAS.
SQL Server.
SQL Server Analytics Server. But it's part of, if you go to Microsoft's website, they'll give you the full blown of Microsoft SQL Server for free in Developer Edition, and you can play with SSAS.
Okay.
It's a data cubes and data lakes are very interesting technology. So it's again, I've been doing this since '99, right? And so, when I started, SQL Server 2000 had just been released, which was a major change from SQL Server 6.0. SQL Server 6.0 is just a glorified Access database. It really was frighteningly bad. 2000 changed it to where it was an engine, because Access, I keep referring, I think probably you heard the spiel. And Brian, if you watch the other videos, it's there. When you talk about SQL Server as an engine, that means it's constantly running in the background.
Yep.
Okay. Access isn't an engine. It's just a database that sits there and doesn't work until you tell it to, right? It's not constantly running. So SQL Server 6 was more Access than it was SQL 2000, right? So 2000 became the first engine, and they started running the stuff in the background. But so when I started on SQL Server, like the biggest database that I dealt with on any kind of regular basis was maybe 5 gigs, maybe 6. Because that's all SQL Server would handle. It would only handle like a 6 gig database, and then you were really pushing it. But with each database version that came out, and MySQL didn't really even exist back then, because MySQL came around the mid 2000 as an open source database system, until Oracle bought it, and then now it's not free anymore. But like databases now, the smallest database that I have in my day job is probably 250 gigs. The smallest. Biggest one I currently have is 214 terabytes. Which, if you think about it, is frighteningly huge for a database. But then you think, how does that get stored on the disk? How do you have a 214 terabyte disk and you return a query in less than 3 microseconds? Good
indexing.
Good indexing. Good indexing and really good and
robust hardware.
Robust hardware, yeah. Actually, the funny thing is, so when you're doing your disks for your databases, we've got low performing disks, high performing disks, and mid performing disks. Your databases, your data files actually go on your low performing disks or your mid performing disks. They don't go on your high performing disks because not a lot goes on with them. You're basically just writing to or reading from. It's called IOPS. It's your read and writes. As long as your disk can handle a decent amount of read and writes, it's the disks that there's a database called the TempDB. Okay, remember how I said early on that you take the data from the table and you put it into active memory? Okay, the active memory is referred to as TempDB. So the TempDB creates this structure of data, and everything before it goes to the database. Did I show you guys this? Did I talk about write-ahead databases? How it works? Okay, give me a second here.
But not.
This is really interesting. This is all like origin story stuff here. So you've got your database, right? And then you got your that's the user, right? So now, if I write to the database and I read from the database directly like this, right? Let's say I'm updating 300 rows on this database, and at like row 150, like the connection breaks. right? The database is corrupt because it doesn't know where it stopped or where it began. The database is corrupt because of that, right? So what they did to fix this is so one of the parts of a database engine is something called the log, the T log, the transaction log, right? So what happens is now, instead of the user writing directly to the database, the user writes to the log, and then the log writes to the database. And so what happens here, and this is databases are self-healing to a certain extent. So now let's say I'm updating 10,000 rows of data, right? I start this running over here and I'm writing to the log here. And there's a buffer. And once the buffer fills, it starts writing to the database. And it keeps track of this. And every transaction that happens on the database has something called an LSN, last sequence number. And so the log knows what the last sequence number is, and the database knows what the last sequence number is because it's all kept in the metadata. So what happens is, if the connection breaks and they've only written half the rows, right? Everything stops, or like if the database, when the database comes back up, it looks at the temp log and says, hey, the last LSN I have here is 512. What do you got? And the database says, I've got the rest of it. And then it says, okay, give it to me. And so everything in the log gets digested into the database because it was there. Because the log knows there were 10,000 rows. Here's what the last LSN should be. The database comes back up online and says, hey, I'm at this number, what you got? And the log goes, hey, it were 10,000 rows, I got the rest, let's do this. And it just brings it over. If it comes back up and the database goes, hey, I've got LSN 512, what do you got? And the log goes, hey, I've got 613, but I know there were 10,000 rows. Let's roll everything back. So it rolls everything back to the way it was. So whenever a database crashes or server crashes, when the database comes back up, the server comes back up, the database is listed as suspect until it goes through this process to make sure everything's good. And if everything's good, it comes back up in 15, 20 minutes and everything's fine. If it never comes back up, then it's dead. I think the only time that's ever happened when it's died is when it was a ridiculously huge database that they were doing some ridiculously huge transaction on. And then it comes back as suspect and it never comes back up.
That's why you want backups.
Well, and that's the thing. So, and that's the other great thing is when you back up a database, which is something we never talk about in this class, it's a hot backup.
Yeah.
Which I've had to prove to many people many times because I had a boss who had to prove to literally 7 times because the dude never believed me. So when you back up the database, it's constantly grabbing everything until it's done, and it grabs the tail end and then it's done, right? The trick would be, and it gets dicey, if you have a huge transaction going on and you're trying to back up the database at the same time and it goes down, you're guaranteed for this thing to fail.
Yeah.
There's no doubt. If you're backing up a huge database and you're running a huge transaction in the database and something fails, that database is never going to see the light of day again. And you have to go to last night's backup.
Yep.
Yeah. So anyway, a lot of sidebars tonight. But anyways, that's how, so with the T log, the transaction log, it's called write ahead logs. So the database writes to here. And then when everything works out fine, it writes it to here. Updates, everything happens in the tempdb. And so the tempdb exists between this all. Right? So here's the tempdb. The database, when you ask for the data to be brought to it, brings it to here. Right? So this is on disk and in RAM. So the data is brought to here. All the changes are made here. And this is your check to make sure the changes will work. When that passes, then it writes to your log and then it writes to the database. So you got this whole little thing going on. And again, you update 50,000 rows in 5 or 6 seconds. That's why, and one of the biggest game changers in databases to date is solid state drives. Solid state drives changed the game with databases significantly, because all of a sudden your IOPS went through the roof, because now we're not spinning disks trying to flip things out, right? So anywho, that's way more than I was going to talk about tonight. So do you guys have any questions on what I talked about tonight? Do you have any questions on the final project? Anything along those lines?
I'm good.
Yeah, I have a question.
And the question is,
why
I think we're gonna bail though. I got a meeting to get to though.
have fun.
Okay, we'll see you guys.
Bye bye. Bye, Brian.
Why do we need union if we have this job?
We don't. It's an old command from a long time ago that just never got redacted.
Okay.
Yeah.
Because I'm looking at it, I say, well, I think that join works better than union.
It does.
Okay.
In the database engine world, they keep saying they're going to deprecate features, but they never do. So they just stop talking about it and people forget it's there.
Now, before we depart, when I was talking to you about becoming a analytic business, you say check on Microsoft SQL Server Analytics Developer Edition.
No, so you're going to get Microsoft SQL Server Developer Edition, and in there is an analytics server. It's part of the fun difference between Oracle and Microsoft is, right? With Microsoft, everything you want is baked into the one product, and it doesn't cost you anything more. So Microsoft is like Delta. You get your seatbelt, you get your everything, you get your snacks, you get everything. Everything's in the one ticket price. With Oracle, it's like Spirit Airlines. The $50 gets you the seat, but if you want a seatbelt, it's another $12. And if you want the oxygen mask, it's another $15. And if you actually want the plane to stop to get off, it's like $12.
Yeah,
right?
Because Oracle bought the free version, and then you want to make money out of it. But But so Microsoft developed their own system.
They bought it. They bought what was it called? Oh, what was the system they called bought? They bought a system.
Okay.
And they adapted it. That's Microsoft does that. Microsoft is like the Borg.
Okay.
They just buy systems and mark them there. But if you download Microsoft SQL Server Developer Edition, when you install it on your computer, you'll have a choice to install something called Analytics Services.
It might be expensive, that system from
what's
Microsoft.
That?
It might be expensive, that SQL Server.
It's free.
Oh, it's free. Oh, okay.
As Developer Edition is, if you want to actually buy it to use as a database, it costs a lot of money. But if you just want to use it to play with, Developer Edition is free. And it's the full version of it's got every bell and whistle that's there. So you can download that, put it on your system, play with Analytics Service. There's a bunch of resources that you can get, like on Udemy and Pluralsight and YouTube. Just look up SQL Analytics Services, and it's going to walk you through it. It's a really, if you want to get into data analytics, that's a great start. You also want to, the thing with data analytics now, there's a lot of machine learning and AI that goes with it.
Yeah.
So I know the company I work for, we just got a tool that's AI that actually digests the error logs of the databases and can forecast problems before they happen. Okay. There was this one thing, it was called Robot Data, I think it was. I saw them at a show like 3 or 4 years ago. It was one of the first AI engines I saw. They had developed a system for banks where the AI system consumed all the loan applications of people who have ever gotten a loan. And then it consumed all the data of all the loans that were awarded based on those applications, how well they were paid, when payments were missed, who defaulted on their loans, blah, blah, blah. And it set up this algorithm to where it looked at the questions that were on the application, and it said, okay, if this application, you answer the question this specific way, 90% of the people who answer these questions that way defaulted on loan, they're automatically denied. So now when you apply for a loan or a credit card online, it goes through an AI engine, and the AI engine decides whether or not you should get the card.
Okay. Oh, then this is getting scary. Then Elon Musk was right when he said AI is far dangerous than what we think.
Oh yeah, absolutely. I mean, the guy who created ChatGPT went before Congress and said you need to regulate this before anything happens. You already have AI being used in the election cycle right now.
In the election?
Yeah. A couple weeks ago, someone programmed an AI engine to call voters in New Hampshire using Joe Biden's voice and tell them not to vote in the election.
Now that we are talking about this, let me tell you a short story.
Sure.
In 2017, so that's going back a couple of years ago.
Yep.
I was driving to Historic Closet, and I normally used to listen to NPR. I don't listen to news any longer. But when I was getting to the house that I was working, there was something that came up on NPR. The British Royal Army, or the Air Force, they developed an airplane, artificial intelligence airplane. Now, the job of that airplane was to detect where a crime was going to be committed. By itself, it turned out nobody did anything. The airplane by itself turn on, pick up, go where the crime is going to be committed, wait for the person and kill it before he commit the crime. Right. So I said that to a professor, and he said that it was like fiction. I said, well, that's what I listened here on NPR. And, you know, it's stuck in my mind. But like a year ago or less than a year ago, because I told this to my supervisor, I think it was on Yale University or Harvard. The artificial intelligence department developed a robot. Not one. It was like 3 robots. Now, those robots, they kill like 3 or 4 scientists in the university. That was not on the news. You have to look for it. But it killed them. So the security department came and they destroyed the robots. 3 of them, they destroyed. When they destroyed the last robots, they came to look into the first robot that they destroyed, and that robot was assembling itself again.
Yep. Yeah, that's classic. That sci-fi of yesterday is reality today, so that doesn't surprise me at all.
Now, what makes things worse for me, and what makes things scary, there is a movie. There is a new version and an old version. The new version is Keanu Reeves. It is called The Day That the Earth Still Stands.
Oh yeah, that's a great movie. With what's the robot's name?
Keanu Reeves is in the last version. The first version.
The first version is black and white. It was way better.
Yeah, it was way better. But if you go and you watch the last remake of Lost in Space, you know why the robots were following the group of human that were going to Alpha Centauri.
I don't think I ever watched the movie. I watched the TV series when I was a kid. I don't think I watched the movie.
Yeah, they got like three series with different episodes.
Yeah. You mean the Netflix series? Yeah. I did not watch that.
Where that is interesting to watch it because of what is going on nowadays. Now, this is the thing. Those robots were trying to destroy because somebody steal a special reactor from them.
Right.
because we didn't have the technology to go to Alpha Centauri because of the energy issue that we have, because we have combustion. And in order for you to travel into such space, you need something special. Those robots, they made themselves somewhere and create all this on their own. Now, if you look into that and then you remember Terminator, this is weird. You know, it is like, hey guys, you are watching what is gonna be your future if we keep going on this path. You know, so it is weird.
Yeah. Oh no. Yeah. I agree. I agree. It's what a strange new world we live in.
Yeah, and you know, I have a friend that lives in Salt Lake. He used to be a state president. He used to be the church education boss in the Caribbean. Very well educated guy. He's a doctor in medicine.
Right.
And what he told me is surprising. He told me this: Pablo, before the second coming, there are things that are going to happen. One thing is, doctors are going to be reviving people without problem before Jesus comes. That's one thing. And the other thing he told me, I saw Jesus Christ inside kind of his spaceship. You know, because he traveled in space. He doesn't travel like people think that he just appeared. He got a transportation system.
Right.
He said on the transportation system, inside the space, it was only like a seat, but there were no control system. The way that he controlled everything was through his mind. The problem is the enemy knows that. And the enemy is using that knowledge and giving it to certain scientists to develop that technology. That way, when Jesus Christ comes, the technology is here already. And then people won't believe into what Jesus is saying, because people are going to say, okay, what you're giving us, we already got it.
Right.
That was something like, it has made me think, you know, but anyway, that's what I wanted to tell you. But, you know, this technology is weird. This AI is weird.
Oh, yeah, absolutely.
As Solomon said, nothing is new under the sun.
It's true.
Whatever we see today, we already saw it. It already exists.
Yeah.
You know, it's already recycled.
Yep.
You know, just look at the world we live. Okay, brother Don, thank you for the time.
You're welcome. My daughter was leaving, so I was just saying about her. All right. Okay, brother. I'll see you next week.
I'll see you next week. Okay. Have a good night and thank you.
Bye-bye.
Bye-bye.